皆様よろしくお願いします。Good afternoon, everyone. Thanks for coming to hear my speech. Today, I will be discussing the challenges that arise when integrating an Epub Viewer into a modern Android app. Firstly, let me simply introduce myself. My name is Bing. I work as a senior Android engineer in Unix. I have a deep passion to code cool mobile applications. Beyond my work, my interests extend to a few non-digital favorites: cats, hiking, and aquarium. This is my small bright aquarium in my house. Okay, before the speech, if you want to check out the sample code or slides by yourself, you can directly scan the QR code displayed on the screen. In this presentation, I'll start by providing a brief introduction to Epub and the basic structure of a modern Epub Android app. Next, we'll dive into the challenges when implementing a real Epub app, focusing on issues related to AndroidView and the synchronization between AndroidView and other composables. Finally, I'll share more tips and advanced features of Epub Viewer to enhance your implementation of a full-functioned Epub app. Today's speech will be centered on Epub integration into modern Android apps. I want to clarify we won't be delving into specific Epub features or basic composable skills, as they are not our primary goals today. Okay, let's go into the first section. What is Epub? Epub, short for Electronic Publication, is an open standard for ebook distribution that enjoys widespread usage. It supports for two types of layout: reflowable layout and fixed layout, making it able to render various types of ebooks, such as manga, magazines, novels, picture books, and more. The latest version, Epub 3.3, was released in May of this year, demonstrating the continued evolution of this standard. There are several Epub SDKs available to help in implementing the Epub Viewer. In my sample app, I opted for a non-commercial solution known as the Sky Epub SDK. Epub SDKs provide various crucial purposes, such as providing DRM solutions and offering APIs and events to simplify the rendering of complex book viewers. The SDKs I have researched all typically employ the Epub Viewer as a traditional AndroidView component. Therefore, our Android engineers face the challenge of integrating the Epub SDK within a modern Android structure. This involves establishing seamless connection between the Epub Viewer and the current Jetpack composables or other frameworks. Then let's go to section 2. The basic architecture of my sample app follows Google's official recommended app architecture, which includes the three essential layers: UI layer, domain layer, and data layer. It's quite basic knowledge of modern Android development, so I'll explain this section very simply. Let's start from the bottom. In the data layer of my sample app, we have a database to hold data even when the app is closed. This layer also supports for any necessary API calls. Moving forward with the domain layer, it takes on some Epub-specific functions that go beyond what the SDK provides. So in my sample app, I have added the two classes, the Epub file handler and Epub file reader. Now focusing on the UI layer, which is the central component today. It imports the Epub SDK and serves as the bridge to transferring data from other layers into the UI elements. Now let's come into the actual implementation and the challenges we face. It's the main part today. The challenges can be categorized into three main parts: AndroidView, other composables, and how to synchronize between them. We'll explore each of these challenges one by one in detail. First, let's address the challenge of integrating AndroidView. We need the AndroidView composable to wrap the traditional AndroidView inside Epub SDK. Here is a sample code from the official guide that demonstrates how to effectively use the composable. Based on the official guide, it's evident that the factory block in AndroidView is quite similar to the uncreated function. On the other hand, the update block is invoked during every recomposition, and we can think of it as some unrecomposed function, even though such a function doesn't really exist. Okay, here comes the first question today. Can we simply set all initializations in factory block and all UI update in update block? The answer is no. If you don't want to come across the allowing loading every time state changes, rotation changes, or any other triggering event occur. This approach also will face other performance issues. Okay. To check the question more detailed, let's check how the code works actually. Firstly, for the factory block, the original code says it will be called exactly once to when the AndroidView is created. Therefore, it's best suited for tasks like constructor calls, one-off initializations, and setting up listeners. We can check the code together. It totally follows the official guide. I just set constructors, initializations, and listeners in it. This block is not that complex. But please note, as factory block will last from creation until the screen destroyed. If you want to trigger a state inside it, it's advisable to use remember update state function to always access the newest state. Then let's check the update block. The guide says it runs multiple times when internal state changes. In practice, don't make this block too long with several states, because every single state change will make the whole block reprocessed and the whole view recomposed again. So just be careful to use it for the state change causing the whole view recompose, and avoid using it for partial view changes and event handling. Here is the quite simple sample code. It's clear that in cases when you want the entire viewer to recompose, handling state changes like the font size within the update block is appropriate. This approach leads to the desired recomposition. Okay, here is another note. The update block will also be called when the factory block is called. Usually, we don't want the viewer recompose during the initial creation phase, so use a conditional statement to skip it. In addition to the situations we discussed earlier, we employ compose side effects to handle the remaining scenarios. For instance, disposal effect manages lifecycle-aware functions, while launched effects can handle the event or other partial view changes. Also comes the code. Here is the way by disposable effect we can manage viewers' lifecycle-aware functions inside it. And then the launched effect side effects, you can handle the events shouldn't cause the whole viewer recompose. Then let's talk about other composables. For a simple example, I want to create a very simple sidebar composable that overlays the Epub Viewer. The composable code is quite straightforward, so I'll present the entire code for you guys to have a quick overview. Okay. Now let's come into the synchronization process between the AndroidView and other composables. To accomplish this, we need to master two essential skills: effective state handling and seamless data flow. First, let's think back the scenario where we have a complex UI. We usually have a structure including view model like the one shown on the slide, handling state for the UI elements. The view model serves as a bridge for transferring data, handling UI input, and managing business logic, ultimately changing these elements into the UI state. On the other hand, UI elements play the role in transferring the UI state into different UI display and aiding in the conversion of user interactions into UI input. And here I have a plus slide for my real sample app. It's a little different from the Google suggested architecture. So also, my sample app also includes the contract and event handler to further clarify its architecture. The contractor component contains a well-defined list of UI inputs and states through interface, offering a clear structure for communication within the app. As for the event handler, as the name suggests, it's responsible for managing events, including scheduling, updating, and consuming them. Moreover, it can be shared among multiple stakeholder classes, enhancing the overall efficiency of event management in the application. Then let's return to the question, how to handle state if we have a complex Epub viewer and several composables connecting with it. These UI elements involve plenty of user interactions, of course, which needs lots of state handling inside. To understand the scale of state management at this situation, I list up part of the state currently on the screen. However, in the case of a full functional Epub app, the actual number of states required can be 5 to 10 times greater than what's listed here. So the question is, how to manage the state in a good way. Maybe we should look back to check our goals first. The foundational principles we aim to uphold include single source of truth, a unidirectional data flow, and the separation of concerns. Furthermore, especially for state handling, Google suggests to hoist UI state to the lowest common ancestor, while keeping it closest to where it's consumed. I'm considering reorganization of state and events into two scopes, the view model scope and the UI scope. The view model scope will already have a well-defined structure, and UI scope where we can handle them outside composables. This division not only follows the principle of separation of concerns, but also has a potential to enhance performance. So my solution is using the two types of stakeholder. One is view model, handling the state within view model scope. Another one is a plain stakeholder class, handling the left, simple state with UI scope. I list up their difference on the screen. For the previous list of states, now we can divide them inside these two stakeholder classes. Let's see the example of is loading, which is widely screen used and updated by data layer. So we handle it in view model. The is loading state is defined by mutable state of function. In view model, the is loading is updated depending on UI input. In this situation, we have the unloading state change. And then in UI composable part, observe is loading state to decide whether to display the loading screen or not. Then let's see the example of is TOC visible. TOC stands for table of content, which only affects UI visibility and is updated by UI events. So it can be handled in the plain stakeholder class. In the state data class, the is TOC visible is also defined by the mutable state of function. And I want its survival from configuration changes, so I defined a saver here too. Then in state class, create an open function to update the state's value. Then in UI part, we create state instance by calling remember saverable the blah blah function, and call the update function depending on user interactions. After reviewing the code together, let's gain a better understanding of where to hoist the state. The view model is held in a wider screen place, which ideally should be hoisted by the root parent, such as Epub Viewer screen here. Then be accessed by the children like Epub Viewer success content or arrow content, as well as their descendants. Conversely, the plain stakeholder, which is book viewer state, should be closest to where it's consumed, so I put it in the Epub Viewer success content. And as the children of Epub Viewer success content, the Epub top content and Epub Viewer content are just where to consume the book viewer state. The entire state hoist process is displayed in the chart. Okay. The overall state structure can be summarized as follows. Both the state holder and view model play distinct roles in managing different states and events within their scopes. In summary, here is a comparison about view model, state holder, and by single state value in composables. Regarding view model, it primarily manages the screen's UI state, which Google defines as the information needed to display on the screen. For example, the screen UI state can be the Epub content required to render the viewer. Additionally, view model supports business logic by establishing connections with other layers of the application. An important attribute of view model is its ability to survive configuration changes, ensure data continuity. This capability allows us to place the most complex or large state inside the view model. As for the state holder, it manages UI element states, including properties that impact how UI elements are rendered, including attributes like visibility and colors. The state holder is typically responsible for supporting simple UI logic. Unlike view model, state held by the state holder class doesn't normally survive configuration changes. However, we have the option to use the remember savable function to enable it. Therefore, it's advisable to handle simple states inside the state holder class. Lastly, the use of single-state values within composables is also a good choice in specific situations. Much like the state holder, it's best suited for handling simpler states or simpler data structure within composables. Organizing different state holders properly in your codebase can be significantly enhance both its readability and performance. Now, after deep diving into state handling, let's talk about the second magic skill, data flow. Let's check together if it follows single source of truth and UDF. Here, I want to take current index as an example, as it can be changed by both AndroidView and composables. When one UI element changes it, how to sync with other UI elements and follow the single source of truth is a little tricky. Please note the SDK itself maintains one index value inside. So for our state holder, we handle the index state but need to sync it with the SDK's value. And for UI elements, they observe the index state inside the state holder. Let's check the first use case. When a user triggers pagination inside the Epub Viewer, please focus on the Epub Viewer. Firstly, user starts pagination, the listener inside SDK is triggered. Secondly, the index value inside the SDK changes to the destination page. Thirdly, the listener inside the factory block is triggered. Update index state inside the state holder. Lastly, the SIGBAR composable observes the state change, updates index-related UI elements. Then let's talk about a little more complex use case. When a user adjusts progress within sidebar, please focus on the sidebar. Firstly, the user adjusts the progress. Some on-sidebar change finished listener is triggered. Secondly, an UI event inside the stakeholder is triggered. Thirdly, Epub Viewer observes the event, call an API to require viewer jump to the destination page. Fourthly, the index value inside the SDK changes. The left step are same as previous one. Finally, the UI elements in sidebar observes state from stakeholder and updates. After a comprehensive exploration of state handling and data flow, we have successfully acquired the two essential skills for achieving synchronization between AndroidView and the composables. As a result of our efforts, we have successfully implemented a high-performance Epub Viewer. In the displayed record, I opened an aquarium book and can change the book page by paging, adjusting sidebar, clicking index from inside the book or by table of contents. Furthermore, you have the flexibility to change the font size for the entire viewer. Lastly, let's see other tips and advanced features around Epub. The first tip is essential but often overlooked. By default, the viewer composable will be recomposed with the allowing loading process each time your activity is recreated. If you want to skip this, configure in your manifest file to skip recreation at some specific situation. This small adjustment can greatly enhance the user's interrupted reading experience. The other two is about Epub SDK. First one is when dealing with font style, particularly for languages like Japanese. It's important to note that rendering specific font styles in the viewer can be quite tricky. There may be instances where your chosen font style doesn't render as expected. You need to test it carefully and discuss with the SDK support team. Another one is about nudge file. To get the total page number or other meta informations, Epub SDK needs to analyze the book file each time opening it. For a nudge book file, the analysis process can be quite long. To enhance performance, consider implement caching strategies and explore options to either open the book while analyzing it or skip the analysis process altogether. This choice can significantly improve the user experience. Okay. And then about some advanced features, we can consider other advanced features. Analyzing meta information and implementing custom styling demands a good understanding of the Epub standard. I have included reference links on the page to aid in this regard. Furthermore, for features such as encryption, decryption, bookmarking, and search, it's advisable to seek out a suitable SDK that provides support for these features. Implementing them in alignment with the solutions I have shared can greatly enhance the functionality and user experience of your Epub Viewer app. Okay, to recap today's discussion, we began by exploring the fundamental of Epub and the structure of an Epub Viewer app. We then dived into the implementation process and the associated challenges, which included integrating AndroidView composable and achieving synchronization between AndroidView and other composables. The next, we shared some tips and insights into advanced features to consider when building an Epub Viewer app. Here I also want to envision the future of Epub technology. I believe in the future, Epub Viewer will having more native rendering methods for improved performance and efficiency. And this one is the most important. We might have SDK support for the composable book viewer. Then we are totally no need for the specific handlings I shared today. Furthermore, we will have accessibility improvement, making digital rendering contents more inclusive and usable for different types of devices and use cases. And flexible customization, allowing us not struggle anymore for editing themes, styles, text settings, highlights, and more. I really struggled for many tiny customizations. Here is some reference I used today and the sample code again. Thank you very much for listening my talk. And I will stay here for the office hour and also looking forward to meeting you guys at the after party. Thank you very much.